Looking at another example for section 3.2, we are given the function. It's a cubic polynomial which we have to graph. Now this function is not given in terms of factors. So the first thing we have to do is factor the function. So we can factor out an x here, but I would suggest factoring out a negative x so that we don't have a negative sign in front of the lead term when we factor the rest of the quadratic. So we get x squared, and since I factored out negative sign, this sign in front of the x square will become positive, and we will get x, and then the next one is positive, so it becomes negative, and because x has been factored, so we are left with 1, and there was a 2 in front here. Now I can factor the quadratic as 2x minus 1 times x plus 1. So we can now see our zeros right there. So our zeros are -1, 0, and 1/2. So multiplicity of each of these zeros is 1. So which means the graph will cross the axis at all these points, the x-axis. Okay, so now we can make a table of values, or we can make a sign chart first. It doesn't matter which one you do first. So if I do the sign chart, I have -1, 0, and 1/2. So I can take the value -2 here. I can take the value between -1 and 0, -0.5. Now next one is between 0 and 0.5. I can take the value maybe 0.2 or 0.1, and then here I can take the value 1. So basically at the same time you can see we can have our table of values. So at -2, what is the value? So go on a side or on a scrap paper, work it out. So I'm going to plug in here. So I have a negative, so -2 times, and I plug in -2 in here, I get -5, and then -1. So multiplying this out, you see I get +10 because there are 4 negative signs. So I'm getting the value +10 at -2. Okay, so we get 10. So a sign chart says that there will be a positive function, will be positive here between 0 and -0.5. So at -0.5 or -1/2. So plugging in the values in the factor, we get negative, which is already there, the first negative sign, and then the x is -1/2. And then x will be is -1/2. So 2 into -1/2 is -1. So -1, -1, -2, and then I will get 1/2. So now we have to count how many. Well, value will be just 1/2. negative, but with the negative sign. Okay, so we'll get negative 0.5 or negative 1/2. So this is now negative. And then at negative 0.2, positive 0.2. So negative 0.2, which is, by the way, 1/5 times 2 into 0.2 is 0.4 minus 1, and 0.2 plus 1 is 1.2. So how many negative sign? Well, this is negative, this will be 0.1, and this will give me a negative number. So there are two negative signs, so it means the sign will be positive. The last piece, 1. So when you plug in 1 in the function, oh, by the way, so this value that we have at 0.5, the value we get is negative 0.5. Sorry, 0.2 we are getting negative 0.16. Positive 0.16. Then 1, when I plug in 1, I get negative, positive, positive, positive. So overall it's a negative value. At 1, the value is going to be negative 2. So what is the AND behavior here? Although you should be able to see the AND behavior from the sign chart, but still it's a good idea to mention the AND behavior separately. So if you notice, again, you can make a little axis and show the AND behavior, but we can see what is happening when we are coming from an axis, a very, very large negative number, then the y is way up there. So it's going to be like this. And then on the right hand side, we notice as you keep on taking bigger and bigger x values, you will see that the y is giving us bigger and bigger negative values. So yeah, our function is going like that. Or you can say as x goes to minus infinity, y goes to plus infinity, and as x goes to plus infinity, y goes to negative infinity. Okay, so now keeping this in mind, and let's sketch the graph. So the zeros are -1. Let me use another color. At 0 and at 1/2. And we are coming from up here. We found that at -2 the value was 10. So that is too far away up there. If you want, you can find the value and add another number in the table of values like -1.5. So at -1.5, we are getting a value like -3. Sorry, +3. So at -1/2, the value is over here. So coming down like this, when we arrive here, it should go down. Cut the cross the x-axis and go down. And at -1.5, we found that the value 0.5, we had the value -0.5. So we are here, so it means we can turn like this and come back to the next 0, which is at 0, and straight, coming like straight, not doing this. So it will cross again, but at 0.25, so this is a very small bump here, just like this, and then going down. So this is what the function will look like. So our intercepts are so this is 0.50, this one is 0, this one is -1, 0. This is the min point. This is the local max point, and this is a local min point. So that is how you draw the function. Okay. One thing we forgot to do here, but it automatically, sometimes the other what to say, things that we do or calculate, it gives us information about the intercepts as well. So y-intercept, for example, would have been y is equal to 0, the origin. That's what we see here. So remember now that whenever your a factor has an odd multiplicity, it will cross the x-axis, and it will cross the x-axis straight, like a straight line, like it's crossing at 0 if the multiplicity is 1. But any other odd number, that it will bend and do something, it will lay flat and then become bend again. So this is how you graph the polynomial function.